All right, I have one more example that I would like you to look at and put into your notes. And example 3 on related rates. And this is a very classic related rates problem. Okay, a ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? I know it sounds very confusing, okay? And it is a little bit confusing. So I do want to first, again, kind of visualize what is happening. So a ladder 10 feet long, so this is not changing, okay? The ladder is 10 feet long and it rests against a vertical wall. So I'm just gonna draw like a little house here, okay? Okay, here's the house, let's say. And this is the vertical wall, okay? And I've got a ladder, okay? And it's 10 feet long, it's leaning against it, all right? So again, pictures in math are crucial. They really are helpful to see what's happening. So what's going on? It says that it's resting against the wall, but if the bottom of the ladder, so this is the bottom of the ladder right here, okay, that's the bottom of the ladder, starts to slide away from the wall. So this is starting to move this way, okay? So what's happening? This is moving this way and this is moving down this way, right? Okay, so this is going out that way and this is going down. So I kind of, if I think about that, now I'm gonna just think about it geometrically, right? What's happening is this is a right triangle. Okay, this is a right triangle. This is coming down. So this length right here, okay, is decreasing, right? So that length is decreasing because this is going to come down. Maybe it's going to move. It's going to be right here, right? And that's going to be kind of like that. Okay, maybe it's going to stop here. It's going to go like that. Okay, so this length is decreasing while this length is increasing. Okay, so that's kind of what's going on in that situation. So really important that I kind of take a moment and visualize, right, what is happening. Okay, and that is what is happening. All right, so now I'm going to go ahead and label those. Okay, so I'm going to now just going to go ahead and get rid of that picture for right now. So I have some more space here. Okay, so I'm going to go ahead and just make a picture without all of the extra context there. All right, so basically I have this triangle, right triangle. This is 10, that's the ladder. Okay, if you want to kind of still, visualize it. And I'm going to follow what Andre said, okay? Since this is the vertical length, I'll call that Y. And I'll call this X. Okay, but again, like I said, somebody else could have flip-flopped these, or somebody even could have called it A and B. All right, so that's fine, whatever you choose to call it. Okay, and again, I want to think about this is moving away. So for example, what could happen again is this could fall down and could stop right here, and then it would be going out right now. The triangle would be a different triangle. All right, okay, all right. So what am I given? What am I given in this problem? I am given that the bottom of the ladder slides away from the wall. Okay, so that's right here. The bottom slides away from the wall at a rate of 1 feet per second. So that is my dx dt. That's what I am given. Important to note which one I'm given. So I'm given dx dt and it's 1 feet per second. Okay. What do I want to find? How fast is the top of the ladder sliding down the wall? So I want to find dy dt. That's what I want to find. I want to find dy dt at the exact moment when the bottom of the ladder is 6 feet from the wall. So that's when this length x is 6 feet. So I want to find it when x is 6 feet. All right. What equation am I going to use? Well, it's a right triangle. So yeah, duh, I'm going to use Pythagorean theorem, right? That's what I'm going to use. So Pythagorean theorem would be x squared plus y squared equals 10 squared or 100. Okay, now let's go ahead and take the derivative with respect to time. Okay, so the derivative of x squared will be 2x times dx dt, plus that will be 2y times dy dt. And then the derivative of 100 is just 0. Okay, all right. Let me now go ahead and substitute, right? So I have x is 6. So again, I don't want to substitute. I don't want to put 6 here, okay? I want to wait until I have the derivative. So I'm going to do 2 times 6, that's 12, times, and then what was my dx dt? Well, it was 1, so 12 times 1, plus 2 times, well, wait, what's y? I don't have y. But wait a second. When x equals 6, I can easily find y using Pythagorean theorem, okay? So I know that x squared plus y squared equals 100. Let me put in, well, what will y be at this exact same moment? Well, that's 36 plus y squared equals 100 minus the 36. I'm going to get 64. Y squared equals 64. Y is 8. In fact, it's a 6, 8, 10, right? Okay, so y is 8. And again, I used, right, information that I'm given. So I'm going to put in 2 times 8 times dy dt equals 0. I'm going to go ahead and do a little bit of right algebra here. So this is going to be 12 plus 16. So I got 12 plus 16 times dy dt equals 0. If I minus the 12 and divide by 16, I'm going to go over to here. Whoop. I'm going to get dy dt will be negative 12 divided by 16. And that's going to, again, be feet per second. When I simplify that, that ends up being negative 3/4. So I have dy dt is negative 3/4 feet per second. And that makes sense that it's negative because remember that that y length was decreasing. I don't really have space right here and I'm also running out of time. So I'm going to just say that I would say that yes, right, that the top of the ladder, right, is decreasing at a rate of negative 3/4 feet per second. All right.